Hi, good morning, teacher. Here's the evidence one, argumentative oral exam. My name is Jose Eduardo Sanchez Martinez. And let's start with the problem situation. Well, an organization dedicated to the production and export of vegetable has requested our support to carry out the design and implementation of its computing infrastructure that allows it to meet current connectivity needs and future growth. In each office in Mexico City, Guadalajara, Monterrey, Querétaro, and León, there is a small network that is connected to a local internet provider. The service contracted with ISP are residential, so the connection service to a high-speed serial connection. Currently, the corporation has headquarters in Mexico City, with office in Guadalajara, Monterrey, Querétaro, and León, with vegetable production centers in Saltillo, Querétaro, Guadalajara, and Silao. Today, the production centers do not have an internet connection, and the entire production record is processed manually in the offices closest to the production center. In the last years, the organization has grown rapidly due to the high demand for products in already consolidated markets such as North America and Europe. So the general management is planning to open new production centers and new offices in more cities in the Mexican Republic. This corporation wants to have a standardized infrastructure designed for all offices and production centers that allows to interconnect all its offices and production centers, which is other and allows it to integrate thoroughly and based on the growth needs that will arise. For this reason, we have to carry out a proof of concept that allows the company to analyze the viability of a standardized design for the offices and production center of this expanding company. So we need to we will I will explain the problem situation, the section one, that is the network physical design, interconnection of offices and production centers. So I will explain what I did here. So this is the file in Cisco Packet Tracer. So we have the offices and the production center. For example, we decide to have three in each offices, have three PCs, one printer, and an access point. So in this example, in the router of Leon, we have PC1 Leon, PC2 Leon, PC3 Leon, printer Leon, and AP Leon. So this scheme is in each offices. So for example, in Guadalajara, we have the same PC1, PC2, PC3, the printer, and the access point. In the office of Querétaro, we have the same PC1, PC2, PC3, printer, and access point. In Monterrey, the same. And in each production center, we have the following structure. We have an access point, two laptops that connect wireless to the access point. Here we can see, and one printer. So in the production center of Querétaro, we have the same, two laptops, an access point, and a printer. In Saltillo, we have the same, two laptops, an access point, and a printer. In Silao, the same. And each router of the offices and production center are connected through a cloud PT. And here we have the server of the Mexico City. So this is our physical design, and then we will implement the configuration. Okay, after the section one, we need to to make the logical design of the network. So we, according to the description of the problem situation, that we have an office in Mexico City, Guadalajara, Monterrey, Querétaro, and León, and we have the productions four production centers in Saltillo, Querétaro, Guadalajara, and Silao. And according to our network physical design, we did the logical design of the network. What is in the following in this case in this document? Uh, First, we have to identify the number of segments. So for the offices, we have the LAN segment that here we have connected our the devices. The WLAN segment that it will this will be the connection between the router and the and the cloud, and the segment one that will be connected the router and the switch. And the offices we have the three same segments, the LAN, W1, and product centers. So um, in the design of the our network, we decide to use this network 10.0.0.0 slash uh, 16, because this is a good network because we have a lot of, of combination and direction of IPs. So for this case, the switches configuration, we have the Leon office with the IP switch will be 10.1.1.10, and the gateway of the router will be 10.1.1.1, and the mask will be 255 dot 255 and 244. So the mask will be the same in each switch, and the gateway of the router will change in the third octet. For example, we can see 1, 2, 3, 4, 5, 6. So this will change, and the IP switch will be the same structure in each office. For example, the only thing that it will change will be the number in the octet three. For example, like here we can see 1, 2, 3, 4, 5, and 6. And the router, we have this configuration. For the IP LAN, we have the gateway 0/0. We have this kind of OIP address. And the one we have this. And for the configuration of the devices, the offices of Leon will be the network 10.1.1.0/27. As we say, we will have three PCs in every office and a printer and an access point. So here we can see. And the production, here we can have the IP address from the office and product center in Guadalajara. This is the network 10.1.2.0/27. The product center in Querétaro is the network 10.1.3.0/27. And in the office in Monterrey have the almost the same structure network. The only thing that changes is the third octet, that is 4. And the product center in Saltillo is the same. The octet that change is the third, that is in this case is 5. And Silao we have the same, and that's all. We can have this in this Cisco packet tracer, the file. We can make ping from one PC to another. For example, I will make a ping from PC1 Leon The pin will be to, for example, well, I already make a pin, so I will make a pin to 10.1.3.2. This is in the network of Querétaro. So we have this, and the the ping it will be to PC1 Querétaro. Yeah, PC1 Querétaro. So here we go, and we can see that the packet we receive is 4, so the ping was right. So that's all for this section. So we will continue to the section 3. That is first we need to know there are new needs of the corporation. So this is the description. As a result of the organization's rapid growth and worldwide preference for our products, the organization has decided to automate its production center and take advantage of precision agriculture. So for the central offices, it has been decided to separate the server and employee section and use VLANs to achieve the descent. It is required to name in the configuration of the switch or one VLAN as server CDMX and the second with the name of CDMX employees. In order to manage the switch remotely, it is request to define an administrative VLAN and give it a name of admin. So for the offices in the cities of Guadalajara, Monterrey, Querétaro, and León, the decision has been made to have two different broadcast domains to separate traffic of employees and service. In each office, four printers and server will be installed for inventory control of the nearest production center. For each office, it has been defined that a maximum of 4 employees will work. It is request to name the VLANs of the offices with the name of employees Querétaro, employees GDA, and so on. And the VLAN of the services with the name of Servicios Querétaro, Servicios GDA, and so on. And for each production site, and in order to achieve the automation goals, it has been decided to define 4 broadcast domains. The domains are environmental sensor, ground sensor, services, and employees. For each production site, it is required to install 16 environmental sensor, 100 soil sensor, and a server in charge of storing the information collected from the sensor, 3 high-speed barcode printers, a laser printer, and for this, the office of segment of each production center, there will be a maximum of 20 employees. It is required for each production center to name the VLANs as CEN Ambiental Querétaro, CEN Ambiental GDA, CEN Suelo QRO, and so on. So we start with the section 3, the configuration of VLAN, OSP, and DHCP. So this configuration we can see here in this document. So we start to make the divide or the router, the interface of the router of the gigabit Ethernet 0/0.10. So we divide the gigabit Ethernet in three nets. So here we implement the DHCP and we name the network and implement a OSPF to make the network for each router to connect. And this kind of configuration of the router should be in every router. So in case of the switches, we have to to create the VLAN. For example, here we have VLAN 10 is the services Leon, VLAN 20 employees Leon, and the VLAN 99 is the admin. And we have to decide which port of the switch correspond to to each VLAN. So in this case, the port fast Ethernet 0/1 to 10 will be for the VLAN 20, and the fast Ethernet 0/11 to 20 will be to the VLAN 10. And here we can see we define the gateway of the router or the switch. Sorry. And this kind of configuration would be in every switch. So according to this, we have these IPs for each router and switches. So for the routers, here we have the three VLANs, VLAN 10 and VLAN 20, VLAN 99. And here we have the IP of the every device in every office. So we will make a test. In this case, we choose PC2 Leon, and we will make a ping to for in this case we already tested. So I will make a ping uh, to this network that is um 10.1.2, that is the GDL office, and 98 that it corresponds to the PC1. So I'll make ping, and we can see that the data sent and received are correct. So we did a good configuration of this thing. For the next section, first we need to know the needs of the corporate. So the general management has decided to maintain the contract with the current ISPs, and the new links contract our businesses. With incorporation of business links, we will make our servers public. So 2 blocks of public IP address have been received for each office that will be connected to the ISP. One of the block will be used exclusively for interconnection purposes with the ISP, and the other block will be used to install the NAT service on the router of each office. The router in each office will perform dynamic NAT service for the office and for the corresponding production sites. All servers in Mexico City are public, so they require a static NAT service. So for the section 4 is the integration of NAT and MPLS configuration. So here we can see what we do in this case. In this case, this configuration is for the router of Mexico City, but this is the same for all the routers. So we can show the section of the OSPF. We can verify that this is working, the OSPF, with the network 10.1.7.64. These are the network that we are using. This for VLAN 10, VLAN 20, and VLAN 99, and the network between all the routers. So we can see the configuration for the AIGR RP. So we can see the network here, and the redistribution of the OSPF. So we can see all the neighbors of the AIGRP. So, and then we can create the NAT configuration, the IP NAT inside and IP NAT inside. In this case, and we can make the source this configuration to have a public IP, and to keep the private IP the server will keep their IP like her its private IP and create a public IP. So we have IP NAT inside source static TCP 10.1.1.71. This is the IP private of the server and the port 21. And here we can see the public IP that is 10.255.255.101. So we make this configuration and we will make this for all the IP that we have in the network. So after that, we prove a ping with the IP private of the devices. So we can see for the IP private of this network and this network, the data sends and receive very well. And that's all of the configuration. After the section 4, we have a new need of the corporate. So for the security reasons, the servers in Mexico City can only be accessed via the web protocol. The servers are public and can be accessed through the public IP address you define in the static NAT. On the other hand, the server of the production sites can be accessed exclusively by the FTP protocol. For these servers, as well as Mexico City server, the public IP address must be used to access them. The servers can be accessed from any terminal equipment of the network or from the user's computer. And we need to design the necessary control mechanism. So in this case, we will talk about the section 5, implementation of security schemes. So let's talk about what we do, what we did. For the router, this configuration is for the router from Leon router. So this is implemented in all the routers. So for this example, we configure the IP NAT here, and we make an access list that permit well the all the network that we already have in the router. So and we define the IP NAT, and in this case is static TCP for the specifications. So um, here we can define that we can only allow the FTP protocol. In the case of Mexico City, we make the configuration to allow only the HTTP protocol. That is the web protocol. So in the Mexico City, that have this difference, and we still configuration deny the new host with this IP address. So this kind of configuration is are in all the routers except in the Mexico City, because the Mexico City allowed only web protocol communication. So here we have our Cisco packet tracer file. So in this case, we will prove this point that the Mexico City can only be accessed via web protocol. So in the Cisco packet tracer file, we start from PC to Leon. I define that the IP public of the server in Mexico City is the following. So I will access to the server using the web protocol. The IP public of the server is the following: 10.255.255 and 100. And here we can see how I can access to this server using the web protocol. We say Cisco Packet Tracer, welcome to Cisco Packet Tracer. This indicates that it's good the communication through the web protocol using this IP. And I will try to make the communication using FTP protocol. So I have already this FTP and the IP public of the server 10.255.255.100. So it's trying to connect to the IP using FTP protocol. And we can see um, when it ends, we can see that there is an error. So with this, we can confirm that the specification that is request uh, is working very well because we cannot access, we only can access to the server in Mexico City via the web protocol. So our configuration are good. And finally, that's all. And thank you.